Okay, so our group chose to do our presentation about hockey statistics. So we're running models to try to explain total points for hockey players. We ended up using statistics from the 2008 to 2009 hockey season, since that season's over and they were all complete statistics were available. Over here we have a correlation matrix, but before I explain that, I'd like to say that before we ran any of our models or correlation matrix, we normalized the data, and we had to create one dummy variable, which was for player positions, because there were 4 positions recorded, so 3 dummies were created, and a base of center for position was used in that variable. So the correlation matrix here, I'm not sure if it's very clear on the screen, includes all the variables we chose to run in our model. There are 2 variables, total goals and assists, that are featured here, but were not used in our analysis because they directly explain total points. They are sub-variables of total points, and if you use them in any of the models, they create perfect collinearity. And we also had 2 other variables, which was the player name and the team name, that were not used in the analysis.
We also did a scatter plot comparing one of the independent variables, shooting percentage, compared to the total points, our dependent variable. And as the scatter plot shows, there's a positive correlation between the 2 variables, with some outliers along the y variable. You can see that there are some players who had a 50% shooting average, which was extremely high, and were for the number of goals they actually scored, like 50%. And there were some outliers along the x-axis as well for players who shot really poorly and had, for the high number of scores, they actually had a very poor shooting percentage. And we did a multiple linear regression, we did an exhaustive search, and we chose a subset of the search of 8 coefficients, because we found that for beyond 8 coefficients, their increases in R squared were insignificant, but for a coefficient of 8, there was a R squared of about 91.89, almost 92, and we felt that was the best model to choose.
Okay, these are the results of subset 8 of the exhaustive search. The 7 dominant variables are position, D, games played, plus minus, power play goals, total shots, shooting percentage, time on ice per game, plus a constant term. As you can see, all these coefficients are significant when we see their p-values close to 0. And in the bottom, we have the training data scoring and validation data scoring summary report. The root mean square error for training data scoring is 6.2, whereas for validation set, root mean square is 7 on average. And the average error in the training data scoring is 0.000003, which is quite close to 0. And the validation data scoring, the average error is 0.17. Overall, still under 1. So it is still a very good model when you look at the validation. There may be a problem with overfitting data, but still the validation data scoring as per root mean square and average error shows better predictive accuracy. These are the training and validation lift charts. Both of them have a higher lift, which is very good. But in terms of assessing models' performance, we're using the lift chart for the validation data set, and it indicates this is a good classifier because it gives us the higher lift when compared to the baseline.
Overall, the model is a very good analytic model and good for classifying the data, but for a coach or owner who is looking to predict who to hire, it doesn't do as well for looking for which players might do a good job in the future at scoring a lot of goals for a prospective team. And part of the issue was that some of the independent variables themselves won't be known until the future season plays, like shooting percentage or the time on the ice. You won't know until you're actually in the season. So we felt like, for that reason, we felt it wasn't a weaker hiring model. We also had done a regression model to see as penalty time as the dependent variable, but we found that was a very poor model, and we did that to see if we could predict which players would have the most penalty time, which could hurt the team as a whole in terms of having one less person on the ice and putting the team at risk for being scored upon themselves. But we found that the R squared for those models were very poor, so we chose not to proceed with that model.
And that about wraps it up for our presentation here. A lot of other information that was not featured here, but will be featured in our write-up. And I guess we will entertain any questions about our presentation. Thank you.